Lateral moraine. These are parallel ridges of debris deposited along the sides of a glacier. They are a product of frost weathering and shattering of rock from steepened valley walls carved out by the glacier. Because these ridges form at the top of the glacier, they do not experience the post-glacial erosion of the valley floor, and therefore, as the glacier melts, lateral moraines are usually preserved at high ridges. Medial moraine. Ridge that runs down the center of a valley floor. It forms when two glaciers meet and the debris on the edge of the adjacent valley sides join and are carried on top of the enlarged glacier. As the glacier melts or retreats, the debris is deposited and a ridge down the middle of the valley floor is created. End moraine. This is the ridge of till that forms at the end of a glacier. This forms when ice melts at a certain point but continues to advance forward, depositing its sediment in the area where it melts.
Plucking occurs when rocks and stones become frozen to the base or the sides of the glacier, when are plucked from the ground or rock face as the glacier moves, leaves behind a jagged landscape.
Ice calving, also known as glacier calving or iceberg calving, is the breaking off of chunks of ice at the edge of a glacier. It is a form of ice ablation or disruption. It is the sudden release and breaking away of a mass of ice from a glacier, iceberg, ice front, ice shelf, or crevice. Continental glacier. Continuous masses of ice that are much larger than alpine glaciers. An ice sheet covering a considerable amount of the continent. Desert. An area that receives less than 25 centimeters of rain annually. Seabed. The sea floor or ocean floor.
Glacier dynamics are the motions within glaciers or large bodies of ice.
Ice loss in West Antarctic glaciers has increased by 75% over the past 10 years. The ice loss, which was originally concentrated in the Pine Island Bay area, has accelerated into the 6 major glaciers of West Antarctica: Pine Island, Thwaites, Haynes, Smith, and Polar glaciers, which are the
The glaciers have shrunk by an average of 83 gigatons per year over the past 20 years. This is only accelerating. So this means that if a glacier started here and ended here 20 years ago, it has probably receded to here or even here by now.
That would be the equivalent weight of Mount Everest every 2 years. These 6 glaciers make up 10% of Earth's water levels per year.
The ice melting is partially due to glacier dynamics, which is normal. However, the West Antarctic ice sheet grounding line has dipped into the seabed, which has entered a runaway process and is completely uncontrolled.
The Antarctic ice sheet, which feeds these glaciers, has become unstable and completely disintegrated in 200 years. This ice sheet holds enough water to add 16 feet to sea level.
And there's no mountain, hill, or any other barrier that try or succeed in do anything to stop the glaciers from melting and breaking into the sea.
Water temperature is warmer. More ice is melting into the sea as glaciers bathe in warm water exactly the ice problem. Glacial melting in this area has become the main contributor of rising sea levels in that region.
Right now, everybody's saying that global warming is true. The CO2, the fossil fuels that are being pumped into the atmosphere, are raising the heat by several degrees, which in geological and atmospherical standards are massive.
So pretty much the only way to solve this problem is to cut down on fossil fuels, because what is happening right now is we're burning CO2 and that creates a soot which goes out into the environment, and even though we're creating this soot in more industrial places than Antarctica obviously, the soot travels and it gets on these icebergs and that contributes to the melting process. So it also makes the atmosphere much hotter because of the soot. So really all we can do is cut down on that.
So this is causing all the polar ice sheets to melt. Since Antarctica specifically is a geological desert that has not enough precipitation to consider a regular climate here, it's not getting enough replenishment to actually keep the glacier healthy. Right now it's dying right
All we can really do is continue research techniques
Watch the speed of the melting. European Space Agency's Sentinel-1